Hello everyone, welcome to the Lake Rejuvenation and Management course. This is a collaborative initiative by Bangalore University, Friends of Lakes, Biome, and A-Tree. The purpose of this course is to educate citizens on lake rejuvenation, covering both engineering and environmental aspects.
Today, the second session is going to be jointly conducted by Mr. Girish Parthasarathy and Dr. Asha. So they will be talking about long-lasting structures around lakes.
Happy learning.
This is Mr. Girish Parthasarathy's bio.
Good afternoon to all. I'm Girish here, and I am from Rohini Project Management Consultants. Just to give you a small background of Rohini Project Management Consultants, what we do is we are a project management company. We are established in 2005, and we have been working on a variety of projects, including lakes and as well as many types of buildings in hospitality structure, flyovers. So there's a wide range of experience which we are possessing on the panel. So talking on today's topic, moving forward, today's presentation is going to be on parameters of investigation for lake assets. Okay, so this presentation will give you an insight of what we are going to have a discussion today. Okay. So as you can see in this slide, we will try and understand which assets require geotechnical checks, when and why, then what parameters are checked for each asset, and again why. Then there is a method or what methodology is used for extracting geotechnical samples, where to take, how to take it, then what to do if the tests results fail to meet the specifications. I know this would be a very open-ended questions, right? So the next would be, it's again an open-ended topic like the failure modes and the remedy and repairs. So moving forward, we are going to have, you must have understood till now that we are going to have a roller coaster ride on the whole presentation. So it would be a kind of we are going to dive in. It's, you can say, even a bungee jumping similar kind of a situation wherein we are going to dive deep into a portion of civil engineering and as well as keep ourselves afloat also onto many aspects, because with the limited time we will not be able to cover many things as such, but then we'll try and touch upon vital things. Yeah, coming on to lake assets. So this is what we can broadly classify, right? So you have considering it as an ecological zone or a social zone or a lake sorry, lake periphery. You can bifurcate all the assets. These are all the portions or features which get into a lake, and hence it is called as lake assets, right? There might be some detailing also involved in this. Now we will just try and understand what exactly these assets, how it can be tested, means on the parameters, on what parameters we'll be testing on. Moving forward, let us first understand what are tests. What do we test exactly? You saw all the assets, right? But do you test the assets directly? No. What do we test exactly? We test the materials in different stages. There might be some in raw stage or some semi-finished or some finished materials. Now, based on the test, we means based on the stage and the test result, we are able to decide on the stability of the structure, what damage it has caused over a period of time, how to control it, and what can be a remedial measure for the future, and so on and so forth. So the test results will give us to understand what we are exactly going to do with the component. It might be a bund, it might be an concrete structure or lake bed, anything. Now, when we talk about main components in constructions, all these assets are combination of what you see, this four materials. There is soil, there is water, there is cement, and there is steel. So all this are the main components which are put together and you get different shapes. There might be earthen dams, so you use soil there, right? There might be concrete dams, you use cement there, obviously in a form of concrete. And steel also is a part of it. So we have to test these basic materials to understand how and what is the cause of the failure or the damage which has already been caused. And when you are talking at the pre-construction stage, you will understand a lot of things, how it can be better. So for testing all this, there are specialized agencies who do the testing and results are obtained for consultants like us to interpret. So we'll just give you a insight what exactly we mean by that. Coming on to the same thing, as I already told you, there are stages. Now, what are those stages? There is pre, during, and post checks. Now, pre is that is the time when you design it. Now, the design aspect will be guided by these things. You need to understand the site topography, to understand the land profile. You also have to have geotechnical investigation results to understand the conditions underneath. Obviously, that is very much required because you are going to have some structure which is going to start from the bottom, right? And where to found it. So that is the conditions underneath is very vital to be known. Talking on functional requirement, asset specific, what you want the asset to perform as. Is it a bund? Is it going to be an walkway? Is it going to be something we were discussing about sluice? A lot of things, right? So you also understand the available area and the restriction. This is required for concept and sizing. You have to develop a concept before you plan anything in action. You have to understand how much of that asset is viable for that lake and what is your functional requirement. Coming on to the next point is quality of the raw material. That will make your life easier to understand what construction methodology can be used or what is the quality of the material which is available in and around or at that location. So obviously the cost is a guiding factor to that, right? So all this we study during the pre-stage, pre-construction. During is again we have to keep on testing the materials or sometimes the quality of the works which are already executed or in execution. We'll get into the detail as we move on what exactly this means, what how to test the quality, how to test the materials. We saw all the components, right? So we'll get in detail. We are still at the superficial level to just to understand what we are going to learn ahead. Now, when we talk about the post thing, we will understand the test. There are some tests which can be carried out to understand the stability of the structure, right? Or the quality of water, and even for other components. Then sufficiency criteria on the executed assets. Now, whether you have seen the asset performing to its the to the fullest requirement, as per the design criteria. Let us say you had planned for X, Y, or X output. Are you getting that? So that is all post tests. Right? So moving on further, when we talk about the first component, right, soil. Soil important points to look for is we can have lab tests, right? Lab test for soil will be categorized into these four headings, right? Soil and water testing, rock testing, chemical, and contamination. These are the main parameters where we have this lab test to be done. Now, there are numerable lab tests which we classify into types. Okay, so all there are whatever you are seeing on the screen: classification test, chemical, compaction, shear strength, triaxial. These are all. Now we are diving deep, right? So permeability test, specialized test, rock test, or contamination test. There is a specific methodology to be carried out, or how it will be done to get what accuracy of the result. Those are called as type of laboratory test. Let us, on an overall view, let us understand what these tests are. Classification test, you can get your moisture content test, then specific gravity, dry density, compaction test. Compaction test is a very common test which will determine a lot of things, right? So it's commonly known as proctored test. You have a chemical test which will provide you design parameters for civil engineering materials. Then you have the pH value, sulfate, chloride. These are all which are a part and parcel which comes with the soil. It might be organic content, everything. Now you have rocks, you have compaction. Compaction, we are talking about a detailed compaction test when you get into calculating CBR, that is California bearing ratio, or moisture conditions, or maximum or minimum density, combined relationship testing. These are all tests which are conducted by, as I told you, specialized agencies, specialized people with the experience in doing this. Okay, so moving forward, you also have shear strength, triaxial, even consolidation, permeability test is there, contamination test is there. Contamination is that what we commonly know to understand the metals, organics, and the inorganics pH value. Permeability test also is required. So all this test will guide you, giving you an clear cut picture on the parameters of the soil. So now you understand soil is just not a soil, it is so many things which are actually hidden in soil, right? Let us interpret this, the technical language, whatever we just saw. What happens if we are able to do that and we get this? So these are the results. First thing is, the consultant will be able to select and design the type of foundation. It might be for a weir, it might be for a bund, it might be for a sluice gate, anything, right? So there is a foundation, again foundation even for a building as such. So selection and design for a foundation, you will have all these parameters. So it will be very easy to understand how a foundation will rest and what is the load coming onto the soil and how it will be dispersed. Once you are ready with all the doing the calculation, the person who is going to execute, as we call them contractors, he can quote more realistic and have you can have competitive tenders. You can also plan construction techniques. Unless and until you know what is underneath, you will not be able to know how it will execute, right? So construction technique is guiding you the methodology that will also guide you for selection of appropriate construction equipment. Then cost is obviously a major thing, which is going to be our main focus every time. Then study of impacts, environmental impacts on the proposed constructions, so on and so forth. Any suitable soil improvements are needed, or selecting better soil for engineering structures. So you might have to improve some base of some portion of the soil also, right? So as well, when you go into a much more detailed investigation, what we call, when we are doing it as pre, it is called as testing. When we go into something to have a damage assessment or something, we call it as an investigation, right, where the failure comes into a picture. So you have to know the causes, and then only can you design the remedial works. Obviously, we can't be thinking of totally scrapping the thing and redoing it. That's going to again cost more. The cost again comes into play. So, understanding the soil, what happens is when you take a bore, okay, so bore is taken by different methods. You have auger boring, wash boring, percussion, rotary, and the picture what you see is you see this 1, 2, 3, 18, 17 till 19. So this is the depth, and the consultant or the agency who takes this bore will give you this profile of the soil, whatever is underneath. So once you are able to understand the pattern of the soil, where at the top you have, when let us say it is an asphalt, then you have a sandy silt, then you have sand, different types of soil, right? So based on this, you have at what depth you will incur this. This is again, we are only talking about a representative sample. Now, representative sample, why is it called as a representative sample? I'll tell you. Are you seeing these machines? These are all methods which are used to take out a sample of the soil. Now, there might be a smaller, basically we are only talking about hardly 4 inch to 6 inch, or maybe a feet, nothing more than that. You have auger drilling, then you have, these are different types of augers. You have a flushed one, then you have a rotary auger. So all this, you can do it only at one location. Hence, it is called as representative sample. That does not mean exactly that the entire pattern of that land, that location, would be in a similar way. But you at least come to know what it means. Now, that again leads to us to a criteria where we have to decide where we have to take the sampling. For this, there is again a methodology which can be followed. As you see, there is an uniform grid. You can actually, this is just giving you a representation, right? This can be a lake or a land, anything. You can as well do soil testing, and neither guiding any unit to that. Now, if you are having any structure, let us say in the first I would say this location, right? Maybe you want to have some more borers, from more sampling being taken. You can distribute that in a uniform grid, or as well as an offset grid, or a stratified random. You can go with random thing or a rectangular grid. So this is again dependent on how you want to take the sample. So there is actually no criteria for sampling there, but when you want to have it, it is better that you take the sample right underneath at the proposed structure. That will give you a better view of the soil below, and as well as the parameters of the soil to found it or to improve it, what can be done, right? So this is the sampling criteria. Now let us come on to a very common site, right? Compaction. We have a roller which keeps on, that is what we call as compaction, correct? But I chose this couple of photos because these are some specialized attachments which can be used. Again, we are talking about some big projects where such attachments are available and can be used. It is not for a small establishment to source this or to use this. The first one you can see that can be used for that's a vibro thing, so it will impart more vibrations and you will get a better rolling effect. The second one, what you see, this is for rolling for a inclined one, right? This is actually a JCB, and this is just an attachment. In lieu of a bucket, you can use this attachment. So this for canals, canal lining. So a lot of things you can use this. Obviously, your work would be faster and having a better quality, right? So coming on to principal reasons to compact soil. Why do we compact the soil? First thing is to increase the load bearing capacity. Pure English, but there is a civil engineering behind that, right? Load bearing capacity. Load bearing capacity, as we understand that something comes, the load comes on the soil, it has to disperse. It has to dissipate in the way how it is expected. So if you compact it, the whole thing will act as an one compacted layer and it will dissipate. Prevents soil settlement. The third point is provides stability, right? So the reasons are all the same. Reduces water seepage, swelling and contraction. Reduces settling of soil. Now, we are talking about a compacted soil where you have a water flow. Obviously, you are going to have lesser water seepage, or we will not say practically zero water seepage, but then yes, it is lesser water seepage, right? So we have kind of four types of compaction. It's the same thing for soil or asphalt also. So I just mentioned it is asphalt also. So when you see something on the road also, you will see pretty similar methodology or the types of compaction being done there. You have a vibration, then you have an impact, then you kneading and the pressure one, right? Yeah, now this is very interesting to know. Okay, so consolidation. We should understand what is compaction and what is consolidation. Now you have loose soil in the first picture. You have air and water. Soil is there. You will have voids in it. When you have water added to that, and when you compact it, it will reduce the volume. Okay, it will reduce the volume of the soil and the particles will come will become more compact. Okay, so the air content there is, it would be present but it would be much more compacted, right? Now when you talk about before consolidation, you have to just pour the water and there is no operation of compaction where you use the machines or anything. That is not there when you are talking about consolidation. It is just left for a time to settle, right? So automatically both will yield good results, but compacting will give you faster work, the time for compacting is much lesser than compared to consolidation, which is a natural way of doing it, right? So this is the basic difference. More about soil. When we talk about different types of soil, now what soil is better to what location because of the parameters, like it might be permeability, it might be foundation support, pavement subgrade, it is expansive, or compaction difficulty. We have just tabulated that for you to understand how each soil can be selected. May not be every time we get the very ideal soil to do it, right? But we have to work. We have to work with the available soil. But if you go with sand, for example, let us say, there you know compaction difficulty, it's easy, right? You don't have to actually compact in the sand. You go with let us say gravel, that is compaction is very easy. Now you go with clay, the compaction is going to be very difficult. Similarly, likewise, you go with silt, then foundation support, compaction might be easy, like it's okay, but the foundation support is very poor. The same way for the payments upgrade, if you are going to use, it's going to be not good, right? So coming on to the next point, similarly, one second, yeah, similarly, there are selection of equipments. I told you, right? That is this vibration, all this. So these are the different types where even rollers come in different types. You have a normal roller, you have a vibro roller, you have plate rammer, all this. Okay, we are getting deep now. So, looking into the common types, rammers, vibratory compactors, reversible plates, vibratory rollers, or Ramex rollers. Now, depending on the type of soil, what is the best application, you can understand in this, right? So, for example, let us say vibratory rollers. Best application is at sand and clay, that way, right? So, let's move further. The second component what we are going to study is on the steel. Now, steel is, just to give you a small history. Okay, we call this is the chemical formula, right? Fe is the ion, right? So plain mild steel of grade 250, it was widely used in 1967. Okay, but square twisted bars was introduced in India in 1965. Okay, so likewise, from there is a development. Now you can understand there will be basic two types of steel. One is going to be a plain round bar, and what you see is a deformed bar. Deformed bar is always used for civil constructions. Plain round bar is for some architectural purposes. What goes in concrete is a deformed bar, and we call yield strength for the steel, okay, which we represent in megapascals, MPa. There are some terminologies, very common terminologies. I'll not get into the detail of it, but it is good to understand what exactly those mean. And this is a very common discussion when we say that, oh, you test the steel. What do we exactly test? And what does the parameter means? The parameters elongation, then proof stress, tensile strength, yield strength. So this is the technical definition of it, right? So, based on those parameters only, we define the steel grade. You have Fe 415, 415D, FE 500, FE 500D. that wise and likewise. So what exactly the point two proof stress means is when they do a testing, the lab tests and all will be covered at a later stage. Now we are just understanding the parameters, how it will be tested, or rather, what are the parameters being tested. We take the sampling at site and it is sent to the lab. Now, how it will be tested will be covered later. Now, when we get into all this, are you seeing this strength, this stress, yield stress? This is 485, 500, 545, all this. So it not only means FE 500, but then it has to pass certain criteria of yield stress of 545. So that when it is tested, then only the steel is termed as acceptable. Now, what we do is when we have to understand, then this is the very common thing in steel, right? You have a stress to strain relationship curve. This is how actually at that start there would be an elastic deformation when there is a bending and rebending, and then it gets into plastic, and then strain hardening, and then breaking down. So there is a situation is called as ultimate strength, and when it gives off, that is the failure, what is recorded, right? So this is basically on the steel portion of it. Now coming on to the cement, right? For testing of cement, we are going for this test. These are the lab tests which we conduct normally on the cement kind of a thing. There are different types of cement. We'll not get into that detail. There is normal OPC grade, then you have an hydrophobic, then you have for just for an understanding, there is an for railway, it is a totally different grade of cement which is used for the sleeper. It is called as a sleeper grade of cement. Then likewise, and that's not less than 30 to 40 types of cement which can be used. So each cement has to be tested for all these parameters. You have fineness test, soundness test, setting time. Setting times is what actually it's a very vital thing when we are working in hydraulic structures, right? Then you have strength. Now, based on the strength, you have a quick hardening, so quick strength cement that way. And the heat of hydration, again, you have a low heat of hydration cement also. It's a normally cement the concrete emits heat because of the heat of hydration. That's the reaction what happens when you mix cement and water, right? So at that time you can also choose a low hydration cement, or you can add fly ash that way, right? So this is all consultant who will decide what can be done, how it will be done, and in what proportions it will be done. Coming on to the tests of concrete. Now, all these tests, whatever you see, is conducted by the conduct can be conducted at site or can be conducted at lab also. Compression test, flexural test, then split strength test, non-destructive testing. I'll come to these two major points as workability test and the non-destructive testing. This is more an kind of an interesting topic. So you are seeing a lot of photographs here, right? So the first photograph, what you see here with the rod and the tape being measured, this is called as a slump cone test. This is conducted on a fresh concrete. Now, let us understand why we are doing all this. We have to do this because we need to ensure that the structure gets the correct in fact, slump means viscosity, right? When you have this cone, we get the concrete and put it in the cone, and the cone is removed, and this is called as a slump, right? So the concrete comes down when the cone is removed. You measure the slump. This is what operation is happening. So you have a different there are four types of slumps. You have a true slump, then you have a zero slump, means practically non-plastic kind of a concrete. Then you have a collapsed slump, that is the concrete literally fails. You just take out the cone, it is might be too much watery or something like that. Then you have a shear slump, right? So the next is compacting factor apparatus. So all this is being used for looking into the concrete parameter, right? These are all lab tests. How it is conducted, we'll get into the detail later. Now, what you see here is called as an universal testing machine. At site, we cast cubes when there is a concrete happening of any structure. You cast cubes. These cubes are sent to labs for testing after the curing, or the lab, they themselves come and collect it and keep it, and then they can do. There are different types of curing also. Have an accelerated curing also. You can get a result within 24 hours. Yeah, that we can discuss it later. So this will give you, this is a representative sample of the concrete which has gone inside the member. So you test it, then you will come to know what is the strength of the concrete. The cube is considered as a representative sample of that member. That day, with using the same concrete, you have to cast these cubes. The cube is also of a standard size. Okay. Now, these are all tests which are carried out on fresh concrete and as well as not touching the structure, right? But here, what you see, this operation, this is called as a rebound hammer. This test is carried out on physically on the structure, and the rebound of the hammer is calculated. Okay, yeah. Do you see a scale here? It is pushed in, and then you have a rebound, and the reading comes there and calculate. This is for structures where you have a doubt whether the concrete has been in a good shape or good. Basically, you are doubting the structure as such. This is a very pocket kind of an instrument which can be kept at site, but interpretation is has to be done correctly. Sorry. Yeah. And what you see here is called as a pulse velocity test. Here, this is kind of an what to say. You have an concrete which is already done. You will have to have this electrodes kept there, and it will give you readings. That is based on the grade of the concrete. Basically, when you get the readings, it can be interpreted to the grade of the concrete also, how well it is compacted. It might be, let us say, M30 grade also, but you will, based on the reading, whether it is really M30 or it's something less, you can come to know based on the readings. All this what we are talking about is a non-destructive testing. Destructive testing means it has to be kind of, you have to take a core and again go back to the universal testing machine and test it. So these are some of the results what I have just put it. So workability, you have workability measurement and BB time. Now, when you talk about extremely dry, with this apparatus, the time is taken in seconds is 18 to 32. So very stiff concrete 18 to 10. Stiff plastic is so much. Plastic is so much. Flowing is basically as the concrete comes down, it's flowing, right? So when you talk about workability, also you have compacting factor. These are the uh, interpretations. When you have 0.85, it's low workability. When you have 0.95, it is high workability. And what I told you about the pulse velocity, it is when you get a reading of 4.5, that is whatever grade you are talking about, that's an excellent grade of concrete. Then it is in the range of 3.5 to 4.5, it is called as good. 3 to 3.5 is medium, and below 3, it's doubtful. Okay, so this is a very common interpretation of the concrete tests, what we carry out. Coming on to all this knowledge has to be put in the lake structures or the dam structures. Today we are going to talk about some failures, right? Some failures on the earthen dam. So you can see there is different types of failures which are occurring. The dam might fail because of overtopping. Again, why is it failing? Because of the full water level being there, the compaction not strong, the edge protection not given. Basically, you don't have the riprap there. So there might be many reasons. It will be customized. The solution also has to be customized. Now you see a perverse foundation. We spoke about understanding the parameters below the soil. Probably it's not done. When you are going to have a structure here, it is always recommended that you do a testing right below that, maybe some couple of more points to get a look and feel of the structure, look and feel of the pattern of the soil there, right? So, in case if the soil is good, the top layer can be failed because of the selection of the soil or insufficient compaction. So this is called as a piping defect, right? So there is water flowing. So basically, we understand water is going to find its way, right? So that is very dynamic. So we have to ensure that when it is a free flow kind of a thing, and when we are mixing materials, you have cement, you have sand, you have aggregates, you have soil, you have steel, all this are having different properties. This all has to act in an integrated way. That is where the challenge is. Hence, the geotechnical investigation, design mixes, or for that matter, selection of the correct steel or sufficient steel, every parameter, every aspect matters. Else, we are going to have multiple. We may have multiple failures, or we may have any failures. If you have done the foundation, if you have done the top nice, the foundation might, there is a chance of foundation might fail. If the foundation is good, there is a chance the top might fail. If you are using a weak foundation only at the portion, or you have not compacted it properly, or it is not done, then there might be a slump, right? So There is a lot of things. So hence, when you are talking about looking into the failures, you have to find the remedy, customized remedial action to that. So coming on to causes of failures of earthen bund, as we discussed, it can be classified into three types: hydraulic, seepage, and structural. Hydraulic is overtopping of the dam, wave action towards the upstream side, toe erosion, gullying. Then seepage is piping and clogging. Structural failures, as I just explained, it is upstream or downstream slope failures due to formation of excessive pore pressure, upstream failure due to sudden drawdown, then you have foundation slide, failure due to earthquake, failure due to unprotected slide slope, and even failure due to caused due to water soluble materials, right? So water soluble materials is, again, we are talking about quality of material here. So that is also going to be a very vital thing which has to be seen. So just looking into a remedial action as such, this is applicable. We have everything in IS, right? But this has to be implemented, and it is earlier the better. At the design stage, at the time of execution, it is better you can do this. We have a lot of research which is already done, and there is some proposals which are there to have a protection, like kind of you have a rip wrap, then you have an toe drain, or you have an cutout drain in between, so you have an horizontal filter which can be given. So you have to understand that a lot of things get into getting all this integrated together, right? So a dam section or an earthen dam section, or for that concrete dam section, there are experts who have already written IS. Now what I'm showing is just as an earthen dam section. This can be used as a standard section, but again, this is the basic or bare minimum. Nobody is putting a cap to this. This can be improved, right? This can be improved based on the availability of the or feasibility of the time, as well as the area, everything. Again, we are talking about failures, right? Again, the failures can happen due to anything. You have slab cracks, you have pipe leakages. These are all because of the soil, foundation, right? Basement and pool cracks and leaks. Then you have foundation erosion. You have erosion under the abutments. You have utilities passing. You have sanitary pipes and all. There is a lot of manholes also, which is coming very in the vicinity of the bund. All this, when you are doing it, and then there is an action which is happening, or the consolidation over a, say, the compaction happens, let us say, with a known time period of time, but consolidation will take time. So you have to accommodate everything to understand how it is happening. So there might be leakages. So all this has have to be looked into. So coming on to the topic, what to do if the test fail and to meet the specifications. So this are our recommendations, or this this is an, again, as I said, it's an open-ended topic which can be improved every time. First thing is, first suggestion is change in material. That is pre and during construction. You come to know with, you have tests for soil, concrete, you have for cement, everything. You see that there is a repeated failure in that set of material which you are using. It is better, it is wise to change it then and there, not wait till such time that okay, let it happen and then let something go wrong, or it's going to be okay till xyz time, fine, we'll go ahead. No, change it, get a better material. This is, we are talking during construction. But if you are going to really do it before, that is in the pre-stage, nothing like it. Set the specifications very clear so that the contractor, whoever is going to execute it, is very clear in understanding what is the requirement. Then you have to have a detailed investigation for the failure component. Now, a test, there is, we know this. We are in a situation that the tests have failed. So you need to have a detailed investigation for whatever that failed component might be. Portion of the asset or the complete asset, or it might be failure in terms of structural performance, anything, right? Then look into whether you are looking at a temporary or a permanent solution for the issue. Temporary solution can be till you want that to be last. Now, if you want to improve on the asset, you can just have a temporary solution and then take up the complete change of that asset. Permanent solution, you want to continue that asset, it's newly built or it is built to last long, then you need to have a permanent solution. Again, it is happening in a sequence. Detailed investigation will give you the solution. Then you talk about improvement in construction technology and or deployment of skilled resources. you We already know that whatever has been done has failed. Now that time we should improve our method to execute it. We have to improve our method to change the way how it is being done. That is construction technology. So it might be use of different resources. It might be machinery, or it might be manpower also. Maybe some skilled resources doing the same operation also can give you better solution. The main thing is always have an expert opinion. Consult the expert. Right? Monitor the execution. Now, monitoring the execution is right from the beginning. The monitoring will happen at the time when you understand that there is a failure. Now, how it is being interpreted, how the solution is derived, and what can be done at the time of execution to ensure that the same problem does not get repeated, or you don't create any new problem somewhere else, right? So no, it happens. It happens if you are going to rectify a portion. Let us say you want to there on a earthen dam for that's a very common sight in the lakes also. You have trees growing on the incline or something. So it has to be transplanted or to be taken out. If you touch the core, if the trees are gone to the core, then obviously it is going to be difficult to remove the trees without touching the core. If you do that, you should ensure the core of the core is the center portion of the bund, right? That is where the entire loading is coming onto, and you need to be clear about how it will be protected. Then you have repeated tests on rectified components. There are same tests. We don't have to do any other tests or any specialized tests. There are, whatever we saw, the same tests have to pass this test, right? And getting into more detail, as I told you, maybe if you are talking about a concrete component, you can go for pulse velocity test. That will give you much more better results, more accurate results. Similarly, you can go for good the point one change in material. Automatically, you will start getting better results. And then there is a point which actually comes to a project management kind of an thing. There has to be a defect liability clause that has to be very stringent with the contractor. Now, defect liability clause is something that post completion of the work, whatever time period specified, you cannot have any failures. And in the case there is failures, it is already written in the clause that it will be rectified. It will be rectified by the contractor, right? So that is what is called as a, I have explained it very simple, but defect liability clause in project management language and in contracts, it runs in pages. When how if there is some external what to say, like you have something which, and again there is some other work which has been carried out not by the same contractor, but there is some damage of some work, then the clause will not be applicable. So there are as we say, limitations and terms and conditions. So all that has to be specified very clearly. Additional propping, support structure, customized solution for the issue. We cannot generalize any solutions. Yes, you can take a reference. You can take a reference of the solution. You can take, you can understand what can be done when you have faced similar situation previously or somewhere else. So it has to be customized. Every solution will be customized. Okay, so this is just giving an injection to our mind to just to start to understand these are the possible ways to get solutions, and this can be improved and keeps on going into much more detail, right? So just looking into the two components which are really vital. What do to same like kind of the test fails, then if you have you're talking about soil, then you need to talk about improvement in compaction, change the soil. The soil see improvement in compaction is you do a proctor test, all that we saw the tests of the soil. But when you are seeing that you are not getting the same the desired compaction levels because of the soil or because of whatever reason, there are limitations. As we saw, when you go for testing, you have different layers of soil. Maybe when you go and select the soil for the bund or something, say, you see the top layer and say, okay, fine, 2-3 feet it looks good, you can continue, but you might get debris or something. Normally, as you go below, you start getting better soil, but it is not the case always. And when we are talking about soil requirement here for the lake, it is enormous. You are going to have a lot of soil which needs to come for the bund, which needs to come for the weir, which needs to come for making the basins correctly. So there's a lot of soil which is getting in. So that quantity, first thing is you need to get those quantities. So you select the place, test the soil, accept the soil, and continue this testing periodically to understand that what can be done to improve, or if you want to change the soil source, it can be changed at the right moment. You can watch the color of the soil. Obviously the test reports will give it, but it is as a general thing, you can watch the color of the soil. You can as well as see sorry, you can as well as see how much time it is taking for compaction. When you do a field test, you will come to know the compaction levels. That will all be a guiding factor. Then you have soil improvement methods. Now soil improvement methods is, obviously, you can go for a better soil, or you can mix some additives in the soil. It also can be cement. Okay, there is cases where we mix soil cement also, and improve the properties of the soil, but the cost again, right? So that's the guiding factor. Coming on to the concrete, it is selection of the right mix of the concrete. Now, selection of right mix means you have not. I'm not talking about the vendors. Vendors also play a vital role here. I'm talking about the grade of the concrete. When you think about you are going to do M20, M30, M40, whatever grade you are thinking about, you need to have a mixed design for that. Now, mixed design is something which has to be done using the same source of materials which the vendor would give it to you. It might be on-site mix, or it might be an ready-mix concrete. You have to conduct, you have to get those 7 days and 28 days results sorry, to understand what is the compressive strength of the concrete. Right? So tests on the concrete, pre, during, and post. Pre, you have slump test, which we saw that all that we have to conduct. During is again all that you can come to know about slump test and cube casting and all. Post is, obviously we are talking about something here is rebound hammer, destructive and non-destructive testing, right? So now again, we are coming back to this lake acids. Now you actually know. We'll not get into too much of discussion here. We'll say what exactly goes here, what components goes here. You consider bund, there is soil. You consider rock riling for the bank. You consider islands, weirs. It can be soil, it can be concrete, steel, a lot of things, right? So the components. Now, what we have explained is the component testing. So lake assets is, you can just say it is going to be based on the components tested. So that's what I will end this.
Before I start, I thank everyone associated with this Lake course program for giving me an opportunity. And also, I would also like to highlight my heartfelt thanks to Girish sir. I think sir has touched upon everything, including all the parameters that are required. In fact, during lake rejuvenation program itself, in fact, it was not specifically on the lake. In fact, on any infrastructure. But sir has even emphasized upon all the types of failures, everything. Thank you, sir. I think I don't have much to present after seeing when I saw whatever sir was presenting. But however, keeping in mind whatever the things that were told to me with respect to that, I would like to highlight upon what are the different laboratory investigations that are being carried out on soil. So myself, Dr. Asha. So I am working with CMR Institute of Technology as a faculty over there. I hope my audio is also clear. Yeah, so acknowledgement. So CMRIT, Friends of Lakes, A3, web-based resources, IS as well as any of the IRC code as such. And so I would not be highlighting about any of these things in fact, but I just wanted to tell here, whenever we look into a Bund cross section, in fact, we can see that there are different type of soils that will be used for any type of Bund construction. And this is a typical earthen bund. And in fact, similarly, we'll be having the foundation aspects also. So we generally define the soil with respect to GW, GP, SWSP, everything. So in fact, this is really a geotechnical classification, or I can say like a IS method of soil classification. Wherein we can use it in order to decide upon the different materials that are being used for the bund. So so generally, whenever we do any type of investigations, we have a disturbed or a undisturbed samples and remolded. The disturbed samples can be either a remolded samples or representative samples. So remolded samples, as the case is like, it will be very difficult to ensure the soil is being stratified. We cannot make sure that the same way the whatever the soil is in the field, the same way we have collected it back to the laboratory purpose. Whereas representative is like we are trying to maintain more or less uh, the profile and also the characteristics, but definitely it is not a undisturbed condition. It is a disturbed condition. So whenever it is being disturbed means the water content, the density, everything we cannot ensure that it is being maintained the same. And so generally the tests that are being carried out on soil, I think all these things sir has also emphasized. So we have chemical test, pH, cation exchange capacity, basic saturation percentage, nutrient content, electrical conductivity, and even we can even have different constituents also, the composition we can determine, XRD, SCM, all those things will be highly helpful in determining the chemical characteristics of the soil. And physical test. So basically the physical test involves specific gravity, color, shape and size, density and water content, soil structure, and also the compaction. So specific gravity, in fact, it looks to be a very, people may think like it is a very like a common property. In fact, is it so significant for a soil as such? I mean, with respect to an important parameter as such, definitely it's a very, very important because these days we are having many important materials that have been used as a substitute for soil. For example, fly ash, pond ash, and even as a stabilizer we try to use even other type of mixes and even mine tailing waste or even rubber and so many things we keep using in order to modify the soil. So specific gravity is an important parameter because it even determine the mass of the uh, mass of the structure itself. And all these parameters I'll try to, in fact, color and all is like a visible characteristic, and shape and size. So I'll be trying to highlight a bit about shape and size, density, compaction, and then similarly to the strength and hydraulic test, that is engineering properties, it's shear strength, permeability, and consolidation characteristics. So coming to the experimental studies, so generally, so those are chemical tests and all will be mostly highly important, especially for a swelling type of soil or an expansive soil, wherein we use so many type of chemical admixtures like sodium silicate, or even we use calcium carbonate, calcium chloride as stabilizers. So their chemical test will be highly significant. But very more often than not, we try to avoid the expansive soils for any type of constructions. But however, for payments and some of the infrastructure things, we will not be able to avoid the swelling type of soils. So there we will be going in deep about the chemical test. So in this presentation, I'll be trying to touch upon the soil properties in general for index properties as well as engineering properties. So the physical properties and the strength test generally for the geotechnical perspective, we call them as index and engineering. Index, as the name indicates, it is a indicative of the soil. So what exactly it is like that. So it can be used for identifying the soil, classification of soil, and in order to determine the consistency of the soil and what is the way in which the soil will behave. Now, coming to the engineering properties, we have soil strength, we have soil permeability and settlement characteristics. And these two tabs, I feel like they play a very, very important role as far as you do any type of infrastructure construction, infrastructure development as such. Now, coming to the soil samples from field, I am just listed a few. In fact, I can see like Girish sir has highlighted about all the types of samplers and even the wash boring, percussion drilling, everything sir has I highlighted. I have not put the detailed of all those things. Some of the links, in fact, if this material is being able to reach the users, they can definitely try to use. So I have tried to see in such a way that this will be very easily explained to a person who will be not knowing any of those things. So you can definitely go through it. And it is some of the studies are like with respect to India or for abroad. And now just to I would like to even tell about this is a sampler called a split spoon sampler. So split spoon sampler is a case wherein you can have your sample will be getting collected within this. So what happens is like you can easily use this sample in order to do the any type of undisturbed testing or disturbed whatever it is. And sometimes will not be able to get the core as such. And this is a sampler and this is an auger. So auger and all whenever you do, you'll get only disturbed samples. Now coming to index properties, so we have sieve analysis, then consistency of soil, soil classification, compaction characteristics. So coming to the sieve analysis, so this is a very, very important parameter because this helps us in defining the soil as such, in deciding where exactly the soil can be used. So the general procedure is take 300 grams of soil, it can be even 500 grams, doesn't matter whatever it is, but take some whole number kind of thing and do a wet sieving with a 75 micron sieve. So whenever, what do you mean by a sieve? Sieve is something like our, like a cloth only, but whenever we are going to have a larger sizes, it will be made up of wire mesh itself. So what happens is like, generally 75 micron sieve will be more like a cloth. And we can have a sample, do the wet sieving. So wet sieving actually, I will try to show one video like towards the end based upon the time so that people will get a feel on how to do that. And so then what happens is like if the sample retained will be, suppose it is A, and if the sample retained, actually some sample that is passing through it is B. So if the sample that is retained is greater than, with respect to the original weight, it is greater than 50%, we call it as coarse grain. Otherwise, we call it as a fine grain. So if I get 152 grams of sample that is there on the 75 micron sieve, we call it as a coarse grain sample. So these tests are unavoidable for any of the any of the testing or any of the construction activities. So we have this particles being classified into different sizes based upon the particle size, cobbles, gravel, sand, silt and clay. So generally silt and clay is considered as a fine grain soil. Anything greater than 2 micron, we call it as a coarse grain soil. So this is these are some of the YouTube links wherein you can find out how exactly do we do the wet sieving. I will just try to show one of these videos towards the end based upon the time so that since we are already running short of time, I thought I'll just quickly go through the contents that I'm having. Later I can show you. So the reason for wet sieving, so if you see here, you can see that it looks like a properly dry soil. So what happens is like if you try to do a dry sieving of this sample, what happens? All these lumps, they all get retained on the top itself and we feel that it is a coarse grain soil. But it is not so. What happens is like if you don't do a wet sieving, what happens is like these lumps will stay there. Whereas if you put water on it, these lumps will all break. So only if these lumps are broken, then only we'll get the actual size of the sample. Otherwise, what happens? It will get to a, we will feel like we may wrongly judge the sample as a coarse grain soil. Here also, if you look into it, you can see small lumps. These lumps will break only when it is in touch with the soil. So that is the reason why we have to go with wet sieving. Now, so this is how the slurry will be, and in fact, this is generally the way in which we can sieve. And in fact, there are a number of sieves that we generally use. So larger size mesh will be put here, and a finer mesh will be put here. And larger size mesh, in the sense, generally for dry sieving, we use only the sizes anything above 75 micron. Anything less than 75 micron, we use something called as sedimentation analysis. So probably, as I told you, it is there in the video. Once towards the end, I can show you a few of the things. Or even once a link is there, you can even open and see also. So based upon the sieve analysis data, you'll be able to do a grain size analysis. We'll be able to do a well-graded sample, or it can be a gap graded, or it can be poorly graded. Poorly graded means almost all the particles are of in this size range. We don't have particles in larger size as well as in this size. Similarly, here also we will not have some particles of one size, no, all the particles. So here you can see that this size, majority of the particles are in this size. So what happens is, like these materials, if we use, I mean poorly graded soil or gap graded soil, the permeability characteristics or the consolidation characteristics and all will be getting hampered. So it is essential to do all these characterization studies. Now coming to the consistency of soils. So we know that a soil is something like you add water to it, it will become, first it will become lumps, then you add more and more water, you can see that it will form paste. So what happens is, like soil is a unique material wherein it shows a transition from solid state to liquid state based upon the amount of water present in it. So if the amount of water present is such that it is greater than this value, which is called as liquid limit, we call it as a liquid state. If the water content in the soil is between plastic limit and liquid limit, we call it as in a plastic state. Whereas if it is between shrinkage limit and plastic limit, is in semi-solid state. If it is less than shrinkage limit, we call this as a solid state. So we can see all these soils. We would have all seen the soils, especially when a rain happens when you step onto the ground itself, you would have seen all this without knowing all these phases. And you know that whenever you walk onto a slippery road, what are the chances in which you will be able to skid? So this indicates that the soil is having a very poor shear strength. So these are some of the links to see that. I have some screenshots I will show you. Yeah, so this is a case wherein we will be having a liquid limit test determination. What we try to do is, this is called as a Casagrandes apparatus. And in the Casagrandes apparatus, so this is a cup. So this is a brass cup. In the brass cup, we keep this cup in this inclined position, and we'll try to fill the soil. And the soil that we select is passing 425 micron seam. It is a very fine soil. So that soil, you fill it, and you fill it in this fashion, like this. And then we have some grooving tools. So you can see here one grooving tool. So with this grooving tool, we'll cut a groove. So what happens afterwards, using this handle, we try to give blows to the cup. We can see that the cup will close. So if it is closing in half an inch, then we can say that it has reached a liquid limit. And plastic limit. So plastic limit is also very, very important test, because what we try to do is, like we try to make 3 mm diameter rods by using the soil. And the moment it starts developing cracks on the surface, we can stop. So that means that the water content is the corresponding to the plastic limit. So this is a plastic limit is normally the water content at which generally the soil will be having a very comparatively a higher shear strength. And also we can see that, for example, when it is dried, okay, I mean when you can easily mold it into different shapes, but at the same time when dried it will have a higher strength. For example, you know that during this Ganesha festival, all those Ganeshas and all, we can make it into different shapes, especially only when the soil is in the plastic limit. Because if it is in a higher water content, you cannot retain the shape. If it is in a very low water content also, it will form cracks. Only if it is in the plastic state only. So that water content at which you are able to make different shape, that corresponds to your plastic limit. So this is a thumb rule by which you can identify. So these are some of the ways in which the laboratory test results will be interpreted. So in the liquid limit test, what happens is like, you know that as I told you in this, you are going to give blows to this cup. So as you know that if the water content is more, the cup will come closer. And when the water content is less, it will take more time to close. So the closure we consider only by half an inch or 10 to 12 mm. So what happens is like we try to plot a graph between the water content versus number of blows. The water content corresponding to 25 blows, we call it as a liquid limit. So this is a codal procedure. And similarly, for the liquid limit, we have something called as fault cone method. So either the liquid limit procedure or we can use it by means of a cone penetrometer method. Cone penetrometer method is also same. Only thing is like here we make the cone to penetrate into the soil and we try to note down the penetration. We try to note down the penetration versus water content, and the one that is corresponding to 20 blows is what we consider 20 penetration is what we consider as a liquid limit. Now, these are some of the indices which will play a very critical value, especially with respect to soil condition, especially when they are being constructed in the field. All these parameters will be more relevant, especially when the slope has failed and all. No, they try to understand how exactly it is and accordingly find out how exactly what will be the water content of it and how exactly it has been correlated to the shear strength. So now based on the Atterberg's limits as well as the grain size analysis, we will be able to do the classification of soil. So basically what happens is like from the grain size analysis, we will be able to determine two parameters called as a coefficient of curvature as well as uniformity coefficient. So these are obtained from the grain size analysis. So knowing that as well as the fines percentage, you will be able to determine the soil classification. So generally, according to the IS code, we are having the soil being classified into 18 groups. So coarse grained soil, as I told you, anything that is above 2 mm is called as a 2 micron is called as a 2 mm is called as a coarse grained soil, and we will be having this as gravel and also as a fine grained soil. Since again it is divided into 9 groups. So this is a table which will give you the gist on how exactly we can do the classification. So this is for gravel. So gravel is divided into 4, and again sand is again divided into 4. So these are the sand. So in fact, in the first slide, I showed you how exactly that SW, SP, everything I have mentioned. So knowing this, you'll be able to do the soil classification of the coarse grain soil. Fine grain soil, we consider the consistency limits. So this is the consistency limits. Once we know that, we will be plotting a graph between liquid limit as well as a plasticity index. So what is plasticity index? It is liquid limit minus plastic limit. So knowing these two values, we will be able to classify the soil. So any soil which is having a liquid limit less than 35, we consider this as a we can consider this as a low compressibility. If it is between 35 to 50, it is intermediate, or otherwise it is high. Now, coming to the compaction test, it's a very, very important test as far as any embankment construction is concerned. And core cutter method and sand replacement method are the tests that helps us to determine the quality of construction in the field. So generally the compaction method, we use a mold, and the mold will be filled in 3 layers or it can be filled in 5 layers for heavy compaction. The rammer weight will also vary based upon the effort of compaction. And we try to plot a graph between the water content versus the dry density. That is, rho d is nothing but dry density and this is water content. And we can see that it will form a typical trend line wherein at an optimum moisture content, there will be a maximum dry density. So this dry density is what we try to achieve at in the field. But always we will not be able to achieve this dry density in the field. So we have something called as degree of compactness. So even in the codes also, they emphasize upon attaining at least some percentage of the lab density, which is considered as a degree of compactness. It will be ranging like 95%, 98%, like that. So these are some of the screenshots on how to do that test. So this is a mold. So we divide the sample into 3 layers or 5 layers as the case as I told you. And we try to fill it in the mold, and there is a collar also. We try to compact it like this. And we generally fill it in layers. So after each layer, we give some scratches using the spatula so as to have a proper continuity. Then we fill the mold like this. We take its mass and we try to determine its water content. So by using these things, we will be able to determine the graph. So we can have a modified density as well as a standard density. Modified density is used for airports and things like that. And as I told you, the core cutter method. So this is how we do in core cutter method. We use this core. So this is very, very important even during the embankment construction. So we push it by using a rammer and we take the mass. And this is sometimes if the fill is very loose, you cannot get the core collected within the core cutter. We use sand replacement method. So this is how we try to do it in the sand replacement method. It is in fact, in the video, as I told you, you can see the video on how to do the test. And once we do all these things, we can, after the embankment construction, we can even check the quality of construction. As I told you, core cutter method also we can use. But what happens is like in core cutter method and all also, like when we are trying to do, we have to keep it in oven. After 28 days only, you'll get the water content. After 24 hours only, you'll get the water content. But there are some instant moisture density measurement devices like Proctor needle, calcium carbide method, infrared moisture meter. So by all the moist Proctor needle also will take 24 hours, but in calcium carbide method, infrared moisture meter, you'll get the details in instantaneously. At that moment itself, you'll come to know what is the water content itself, because water content is the one that consumes more time. Now, coming to the laboratory test, I have told you the first part. Now, let us try to go ahead with the second part. I'll just quickly touch upon that. So, in order to determine the strength, we have unconfined compression test, direct shear test, vein shear test, triaxial test, CBR test. I have not put a tab for triaxial because triaxial you can have so many variations, and to do a proper consolidated untrained test itself, it will take around 28 days. So people with constraints on time and all, they will always go for a unconfined compression test or direct shear test. But triaxial test is always preferred. But because of the lack of time, people will always resort to the other test. So importance of strength, in fact, Girish sir also has emphasized upon that. So I will not tell all these things. I will just try to touch upon the direct shear test. So in direct shear test, what happens is like we will be having the sample being kept here. We will be applying a shear force in this line, and by keeping a normal load here, because simply if you apply shear, the sample will move shear. Shear in the sense it will have a tangential movement, but here we apply a normal force so that the sample will remain intact, but on top of it we'll apply a shear force and we'll find out what is the resistance. So this will give a feel on how exactly the sample is having a resistance to shear in the field. So this is a laboratory setup for doing the shear test. Now coming to unconfined test, so we'll be having, in fact, please you can go through the videos. As I told you, there's a simple procedure for doing that. So generally for unconfined compression test as well as for a triaxial test, we use 38 mm diameter and 76 mm height sample. So this is the sample height, and we try to keep this here, and we'll try to measure the deformation as well as the load resistance, and this is how the sample will look like. So knowing this, we will come to know what is the maximum compressive strength the soil can take, and based on that, we can determine the undrained cohesion of the soil, and accordingly, we can determine the shear strength of the soil. Because always the soil is very weak in shear, because it cannot. We know that the moment you put a leg on the soil, also the soil will try to move to the sides, because it will always try to move to the sides because of its very poor shear strength. But you can compress it if you want, how much ever you want, you can try to compress, but the shear strength is very poor. Now, this is also another procedure in order to determine the shear strength of soil, vein shear test. Here we will be having veins. So there will be veins in such a way that they'll be kept in a mutually perpendicular direction. So 4 veins will be there. It will be rotated. And by using this, we can find out what exactly is the shear strength. Directly will not get, we have the equations which correlate the torque that is applied to the shear strength of the soil. So we try to find out the torque, we know the dimensions of the veins, and using this we will be able to correlate and find out the CU value. I'm not giving you the equations because there is no point in giving the value. I mean the equation as such. So this is a shear test, triaxial test. You can see the sample. The advantage, as I told you, the triaxial test is like we keep the samples, the surrounding. You can see this is a sample. There's dots here. It represents water. So all around we keep water and we do the test in such a way that the soil is in the weakest condition. So we can simulate the soil is in the weakest condition that we can saturate the sample, and which is not so. Always the soil, because only on a rainy day we feel our legs, we will feel uncomfortable to keep our legs onto the ground. But other days it will be quite comfortable. But here when we do the test, we always try to put the worst condition and try to do the testing. So we'll try to do this and we'll be able to identify the failure plane or soil. So by using this, we will get the, we call the shear parameters, that is C and phi. Knowing the value for C and phi, directly we can determine the shear strength of soil, which plays a very crucial role in determining the bearing capacity of the soil. So this is a setup. So triaxial test only and UCC test, the main difference in UCC and triaxial is like unconfined compression test and triaxial is like if you provide a compression, all round compression from the sides, it will become a triaxial. Tri means from all sides we are applying water. That is the meaning. Whereas in unconfined means we are not applying any confinement. That is why it is called as unconfined. Now, this is a permeability characteristic. So we can determine the permeability characteristics of the soil by means of using a constant head method or a falling head permeability method. So this is also, I can tell like it is very easy to correlate in the sense you pour water to the soil, how easily it will come out. You know that if you have sand, it will easily come out, water will come out, whereas through clay, it will not easily come out. So this property is what exactly we are trying to determine here. And we also have a consolidation test. It is very, very important test as far as any embankment construction is carried out. These two are correlated, permeability and consolidation. So this is a test setup for doing the consolidation test. And permeability, I am having the videos alone. Like here you can see the consolidation test. So generally for consolidation test, we use a very small size sample, 6 centimeter diameter and 2 centimeter size. With that itself, you can determine the property of the soil. So this is a sample and you'll have some porous stones in which indicates how exactly the water can be coming out like that. So these are the tests that are being provided under the control conditions. As I told you, it is very easy to do the test in the laboratory because the conditions are in our hands. But in actual conditions, it will be really challenging because things will not be the same as we want or as expected. So thank you. Thank you for your patience.